viewers out there. In the last video, we had discussed on electronics and communication engineering in general. In this video, let's concentrate on the first three core subjects of electronics and communication engineering. This particular core subjects are not basically for GATE alone. It's a overall view of what is electronics and communication engineering. When you happen to get into this particular course, how will you basically have a background check on what is required for GATE. So it's a parallel preparation for your engineering course as well as your GATE exam. So let's have a discussion regarding this. The first three subjects, okay, which is under our consideration in this particular video is analog electronic circuits or devices. The second subject will be logic design and the third will be network analysis. In this video, we'll be explaining in detail about what is the requirement for you people to study these subjects with complete subject details. And before we getting into our first subject, let's just understand why do we need these subjects, what is the difference between these three subjects, okay, a generalized version of it, and then let's get into the detailed knowledge regarding each subject. The branch electronics and communication engineering is originated from this particular technology called as electrical technology. Electrical technology is one of such technology which deals with all machines, tools, devices and system in which a current or a flow of electron takes place through a conductor or a metal. This electrical technology is again broadly classified as power system and signals. When I speak about power system, they are basically the subject or the subjects which deals with generation and transmission of electrical energy. When I say about transmission, they speak about various transmission lines. Okay, it can be wired or wireless. What are the requirement for us to convey the information? And generation are the system which will help us for the transmission. So the next classification is signals. When I speak about signals, signals are basically information. When I say information, information is nothing but a signal or something which you want to convey, okay? What you want to convey from one point to another point in a most meaningful way is called as information. So how do you happen to convey this, okay? Be used on the electrical knowledge, whatever you have. That is basically everything about signals. When we happen to classify on various subjects, signal plays an important role. Based on signal, the system will correlate. Okay, when you happen to use one type of signal, corresponding systems should be used there. So, first let's get into signals, and when we understand signals, we can directly understand the systems. Signals can be represented in two ways, that is either in analog form or in digital form. Okay, when I speak about signals, signals begins in analog form. So we need to understand the trade-off of analog and digital signal representation, that is pros and cons of each. Ultimately, all the circuit functions are analogous in nature and uses analog principle. Whether the circuit is analogous or digital in nature, analog functions are always a must. Now, why is it a must? Okay, let's just have a view. Okay, let's just imagine we are dealing with a pure digital circuit that merges with zeros and ones alone. Okay, it happens to work along with zeros and ones alone or few number systems. Okay, in these digital circuit also we may need some analog function. The major problem with these systems are all the issues that particular digital system can undergo are basically analog function. So in order to rectify the errors or the problems that occurs in the system, you should have the analog knowledge. Okay, so let's concentrate on few issues that should be considered in digital circuits, and then we'll understand why analog is so important even though the world is getting digitalized day by day. The issues that should be considered in digital circuitries are stray capacitance, termination of transmission line, supply of power, interference like noise. All these issues are analogous in function, though the circuitry is digital, a pure digital. Okay, it's just like how you need your hands to type a computer. Computer cannot work without your hands, right? Though it is a machine, it is more intelligent machine, right? So though we are into the world of AI, okay, we should understand that AI is done by human. It's just that thing, that understanding which is required here. If you know to understand that, you will definitely understand analog circuitry. The human is a complex system. In similar way, analog is a complex system. You need to understand that in order to get into digital. If you don't understand the complex system, you cannot get into the simpler versions. That is what it is. And a proper electronics and communication engineer, to make him even more efficient, he needs to balance up within these two. Because analog works under the time, okay? It works with respect to time, wherein digital works with respect to frequency. You can see that frequency and time are reciprocal to each other. So when a operation or any sort of procedure is time consuming, you should get into the digital format. And when it is even more digitalized that we cannot even understand it, it's overtaking our knowledge, then we need to get back to time domain. And that is the basic balance that is required for an electronics and communication engineer. If you happen to understand this overall concept, I guess you people will understand everything possible. All the core subject will be very easy for you.